Welcome back to Data Dialogues, where we explore the ever-evolving realm of data systems and their impact on technology and society. Today, we're diving into some intriguing concepts surrounding Dataflow systems, particularly how the interactions between write and read paths are transforming application development. So, slip on those headphones and let's get started on this journey together. To kick things off, let's break down what we mean by Dataflow systems. At their essence, these systems facilitate the efficient creation and updating of derived datasets. You can think of these derived datasets as specialized versions of raw data, like search indexes or predictive models. When new data enters the system, it sets off a chain of processes we call the write path. Picture this. You're updating a search index. When a document changes, the system must ensure that all related queries and derived datasets reflect that change. This is where the write path comes into play. It's all about pre-computing the necessary updates as soon as the data arrives, regardless of whether anyone is actively searching for that information. On the other side, we have the read path. This is where the action happens when a user requests information. When someone queries a derived dataset, the system retrieves the data, processes it as needed, and serves it back to the user. It's a bit like a restaurant experience. The write path is the kitchen preparing meals in advance, while the read path is the waiter bringing those meals to the diners. Now, let's explore the implications of these paths a bit further. The derived dataset serves as a bridge between the write and read paths, representing a trade-off. If you invest more effort during the write phase, you can respond to read requests more quickly. Conversely, if you conserve resources during writing, you might find yourself doing more work when it comes time to read. A practical example of this is caching. By storing the results of frequent queries, systems can quickly serve those requests without needing to access the underlying index each time. This approach not only speeds up response times, but also optimizes resource usage, which is crucial in today's fast-paced digital landscape. As we look ahead, it's important to recognize how the traditional client-server model has influenced our understanding of application development. In this model, clients are typically stateless, while servers maintain control over the data. However, with advancements in technology, especially in mobile and web applications, we're witnessing a shift towards more stateful interactions. Modern applications frequently utilize local databases on user devices, allowing them to function offline and sync with remote servers when a connection is available. This shift opens up exciting opportunities for user experience, particularly in areas where internet connectivity isn't reliable. Consider this. When you load a web page, it doesn't automatically refresh to show the latest data from the server. You have to manually refresh the page to see updates, which can lead to stale data on the client side. However, with newer technologies like WebSockets and server-sent events, we can establish a continuous connection between the client and server. This allows for real-time updates directly from the server, keeping the data fresh and relevant. Extending the write path to include the end user is truly a game changer. It means that every interaction on a device can trigger state changes that flow throughout the entire system, from the user interface to the backend. This creates a more responsive architecture, where changes can be reflected in real time across devices. But why haven't we fully adopted this model yet? The challenge lies in our ingrained assumptions about stateless clients and traditional request-response interactions. Many existing databases and frameworks are built around these concepts, making it tough to transition to a more dynamic, publish-subscribe model. To truly leverage the power of Dataflow systems, we need to rethink how we build applications. Instead of just querying the current state, we should consider subscribing to changes. This shift could lead to more responsive user interfaces and improved offline capabilities, ultimately enhancing the overall user experience. Let's also touch on the interplay between read and write paths. When a stream processor writes derived data to a database or cache, it creates a boundary between the two paths. This setup allows for efficient, random access reads without the need to scan the entire event log. However, we can take this idea further by treating read requests as streams of events. Imagine sending both read and write events through a stream processor. This would enable the system to respond to read requests by emitting results back to an output stream. It's a fascinating concept that blurs the lines between traditional database interactions and streaming data processing. By treating read requests as persistent joins, we can create a more dynamic system. For instance, a one-off read request might simply pass through the join operator and be forgotten, while a subscribe request would maintain an ongoing connection, continuously updating as new data flows in. This approach also allows for better tracking of causal dependencies and data provenance. For example, in an online shopping scenario, understanding how a customer's query about shipping dates and inventory status influences their purchasing decisions could yield valuable insights. By logging read events, we can reconstruct user interactions and analyze their decision-making processes. However, there are trade-offs to consider. Recording read requests can lead to additional storage costs and I/O overhead. Optimizing these systems to minimize this burden remains an open research challenge. But if we're already logging read requests for operational reasons, transitioning to a model where this log serves as the source of requests might not be as daunting as it seems. As we wrap up today's discussion, it's evident that the future of data systems is evolving rapidly. By embracing Dataflow concepts and rethinking our approaches to write and read paths, we can develop more responsive, efficient applications that meet the demands of modern users. The shift from a traditional client-server model to a more dynamic, stateful architecture presents exciting opportunities, particularly for enhancing user experiences and improving offline capabilities. As we continue to explore these ideas, let's keep in mind the potential for innovation that lies in reimagining our interactions with data. Thanks for tuning in to Data Dialogues. We hope you found today's episode both enlightening and thought-provoking. If you enjoyed the conversation, be sure to subscribe and join us for our next episode, where we'll delve even deeper into the fascinating world of data systems. Until next time, keep questioning the status quo and exploring the possibilities.